All right, number 5, we want to find the p-value is what it's saying. Find the p-value of the test statistic. So that's just the area under the curve on the z-value once we find our test statistic. We also need to know what side or what type of test we're doing. So it says a publisher reports 80% of readers on a laptop. Okay, so this is telling me that my proportion, true proportion, is 0.8. A marketing executive wants to determine or test the claim that the percentage is actually different. Okay, so when I'm doing my testing, setting up my null and alternative, we're testing that it's different, so that is that this is equal to 8 or not equal to. So this is giving us that we're having a two-sided test. So what that means is once we find our p-value, we have to double it because we have two sides that we're considering. So we'll get a value, it'll be on the left or the right, and we just need to make sure we do the negative and the positive. Oh no, I'll put this as negative. Okay, so we're going to have to take this area and double it, whatever we get either side. Okay, so we have our true proportion, sample size 300, 74%. Okay, so let's plug all this in. We got 0.74 is our sample proportion, minus 0.8, which is our true, divided by the square root, 0.8, 1 minus 0.8, divided by the sample size of 300. Okay, so this is going to give me my test statistic. So in parentheses, I'm going to do 0.74 minus 0.8 divided by, open parentheses, second square root, 0.8, and then open parentheses again, 1 minus 0.8, close it, divided by 300, and close it twice. Check everything is in there correctly. And so this is my test statistic, negative 2.598. The 8 will round up, the 9 will carry over, so negative 2.60. So my value is negative 2.60. Since we are doing different, we have two-sided, so I also have to do positive 2.60. So combined area is the left and the right side of negative 2.60. We can get this from the table. We're going to go to the normal table, area to the left of negative, and we want a negative 2.60. So along this line, and just keep going over. So 2.60 right here, 0.0047. That's also the same thing here. So we just need to double up. So 0.0047. Let's do it times 2. And this gives us 4,900. So 0.0094. And that is our p-value. It's just the combined area to the left or right of that test value. All right, number 5 is also the same, so we'll do that one here as well. This time we have a study taken. We got 1,200, so I'm going to go ahead and start setting everything up. So my sample size is 1,200. Showed that 76% favored the construction, so my sample parameter, sample proportion is 0.76. 1 minus, okay. Now we need the true proportion. We want to use this data. A political strategist wants to test the claim that the residents who favor the construction is actually above 0.73. So above 73, so 0.73. So this time our null and alternative, the alternative is the one that we're testing. So we're testing that this is greater than 0.73. So this is a one-sided test this time. Just testing this upper end. So my p-value will only consist of the area to the right this time. This will be p less than or equal to 0.73, but we don't need it for this problem. So I need 0.73, and I need 0.73. Okay, so once again, I am going to second enter, just type over what I have here, and add what I need in. So we got 0.76 minus 0.73. So I only got one place. I have to do second, and then the delete button for insert will allow me to add a value. So I can add that 3, and then I can arrow over and change this to a 7. So I get 0.76 minus 0.73 divided by, I got to do the same thing here, second, insert, and I can insert a number, and I can type over that. So I got 0.73 there. And then I'll do the same thing here. So I can type a 7, second, insert, and then add the 3. And I think this is much faster than typing it all in. 1, 2, 0, and then second, insert, add another 0. So here's our value. Here's our test statistic, 2.34. We're not round. So over here I have 2.34. Now notice, if you look in the z-table at 2.34, it's giving you the area to the left, and we want the right side. So we're going to look at the opposite, negative 2.34. So from the table, standard, normal, we're going to look at negative 2.34. So here we go, 0.0096. So that is our p-value.